Okay, so today, when I'm not here, we're going to be working on logarithms, and we're also going to be working on graphing logarithms. So we've already done the exponential functions and transformations of exponential functions. We're going to skip a lot, so keep going until you get to this. What is a logarithm? So a logarithm is another way of writing exponents. So the way that's easiest for me to show this is the swirl method. So this reads as log base b of a equals x. So I can write this in exponential form, and I use the swirl method to do that. So it goes this way. So my base is b, then it's going to go to the x power equals a. So both of these represent the same thing. So log base b of a equals x. So b to the x power equals a. A logarithm with base 10 is called a common logarithm and can be written without the base. So instead of writing log base 10 of x, anytime I have a base of 10, I can just write that as log of x. So if it doesn't have a base, it's understood to be base 10. So on 1 through 6, they're wanting me to write these in exponential form. So I do what I call the swirl method. Some people call it the E. It doesn't matter. So 7 to the second power equals 49. And 7 squared, indeed, equals 49. So we do this same process every time. So 2 to the 5th power equals 32. So number 3, there's not a base underneath here. So this is understood to be base 10. So swirl method still. So 10 to the 3rd power equals 1,000. Swirl method again. 4 to the negative 3rd power equals 1 over 64. So you can pause the video and try 5 and 6, and I'm going to write those out, and then you can unpause to check your answers. So 8 to the 1/3 power equals 2. If you remember, 8 to the 1/3 power is the same thing as the cubed root of 8. 8, which again is 2. 9 to the 3/2 power equals 27. There we go. So to take it from exponential form to logarithmic form, very similar process. So we use the swirl method. So it's going to be log base 5 of 25 equals 2. So if you swirl it again, you should end up with what you had over here. So I'm going to swirl. So log base 8 of 1 equals 0. Swirl it around. Log base 3 of 1 over 81 equals -4. So you could pause the video, try 10 through 12, double check it with my answers here in a second. So log base 12 of 2 root 3 equals 1/2. So log base 10 of 1 over 10 equals -1. Or, if you remember, you don't have to put the 10 since it's base 10, so you could do log of 1 over 10 equals -1. So log base 16 of 8 equals 3/4. So we're going to evaluate the following logarithms using our knowledge of exponents. So I can, since I'm wanting to find the answer, I can set this equal to x since I don't know the answer off the top of my head right now. So 6 to some power is going to give me 36. Well, 6 squared is 36, so x equals 2. Same thing with 14. I can set that equal to x. So 2 to some power is going to give me 128. So we can have 2, 4, 8, 16, 32, 64, 128. So 2 to the first, second, third, fourth, fifth, sixth, seventh equals 128. And we just keep going with these. So I can set this equal to x. There's no base here, so again, that's understood to be a 10. So 10 to the x power equals 1 over 100. That's going to be -2. Again, set this equal to x. 16 to some power is going to give me 2. Well, if I think of it like this, 16 to some power gives me 4. The square root of 16 is 4. Well, I can write the square root, since I'm doing exponents, x would equal 1/2. So the fourth root of 16 is going to be 2. So x is going to equal 1/4. So here, 3 to the x power equals 1 over 27. Well, 3 to the third equals 27, but I need 27 in the denominator. So x equals -3. And for this one, again, it equals x. So 8 to the x power equals 1. Well, anything to the 0 power is 1. So x equals 0. So some logarithms are not as easy to evaluate, like the ones we just did, and will require the change of base formula. So if we have one that we can't figure out easily because it doesn't go into it, or it's not like squared or cubed or whatever, then we do log of A divided by log of B. The log button is on your calculator. And you only have a scientific calculator, but the log button is on your scientific calculator as well. So for this one, I would do log of 34 divided by log of 5. Now in your calculator, you're just going to type in, there's a log button, 34, close the parentheses, and then you're going to divide by log of 5. And that will give you an answer approximately equal to 2.19. So for 20, I'm going to take log 98 and divide it by log of 2. Because for this one, if I do 2 to the x power equals 98, that's not common knowledge. So we do change a base, and we're going to get an answer that's approximately equal to 6.61. So 21, again, if I take 20 and raise it to some power, it's supposed to give me 4. I have no clue what that would be. So we use change of base, so log of 4 divided by log 20. And that's approximately equal to 0.46. So you could try the next 3 on your own and pause the video and double check. So log of 2 divided by log of 6 is approximately equal to 0.386. Let's do 0.39. And then log of 225 divided by log 3. That's approximately equal to 4.93. And then log of 1/2 divided by log 8 is approximately equal to -1/3. Okay, so a natural logarithm with base e is called a natural logarithm and is written as ln. So log base e of x is the same thing as ln x. So ln x equals 4, so they want it in exponential form. Remember, this is the same thing as log base b of x equals 4, base e. So e to the 4th equals x. So again, here, ln 10 is the same thing of log base e of 10 equals x. So e to the x equals 10. Now we're going to go the other way. So again, you can use the swirl method. So log base e of 50 equals x, which we can write as ln of 50 equals x. And again, swirl method here. So log base e of x equals 0.5, or ln x equals 0.5. Approximate the value of each expression. So again, this is a button on your calculator. You're literally just going to type in ln and then 64, and you get approximately 4.16. You're going to type in ln of 1/3, and you're going to get -1.0, or let's make it 1.1. Okay? We're going to skip some more. We'll do the properties when we, before we start solving equations. So we're going to skip, and now we're going to go to logarithmic functions. So we're going to talk about this, and then we're going to do examples 1 and 2, and then we're going to be done. So a logarithmic function is the inverse of an exponential function, and we just did exponential functions. So the parent function for a logarithmic function is f of x equals log base b of x. So when I graph my exponential function, which here we have f of x equals 10 to the x, it's going to look something like this. Rough sketch. Okay? Now, remember when we did inverses, two functions are inverses of each other if they will reflect over y equals x and still be a function. So my x and y values switch spots. So a log function looks like this. So the key thing that you need to remember with an exponential function, and if you remember, which we're going to check the homework when I get back on Monday and go over it, exponential functions, we have a horizontal asymptote. Which will change. Normally it's y equals 0, but it can change depending on if my graph shifts up or down. My logarithm functions have a vertical asymptote. And they will not change if my graph shifts up or down, but it will change if it shifts left or right. So my exponential functions, the asymptote changes as it shifts up and down. And my vertical asymptote will change depending on if it shifts left or right. So there's my two parent functions. So graph each function and identify each characteristic or its key characteristics. So here's my logarithm function. So since my base is bigger than 1, it's going to look like this. Let's see if I can make that a little bit better. Okay. So remember, these two are inverses of each other. So my domain of this exponential function was negative infinity to infinity, which means that's going to be the range of my logarithmic function. So my range is going to now go from negative infinity to infinity, and my domain is what my range would be for the exponential function. So my domain here is going to go from 0 to infinity. And remember, this one has a vertical asymptote. It didn't shift left or right, so it's going to be at 0. So there's my asymptote. And then we're going to fill in some of this other stuff. So my asymptote is x equals 0. It's going to be increasing because you can see my graph increases. So it's going to be increasing from 0 to infinity because it matches my domain. It's not decreasing anywhere. We'll fill in the end behavior once we graph it. Now, graphing this one is a little bit different than when we graph the others. So I can write this as y equals log base 3 of x. Now, what I'm going to do is switch these two and make it log base 3 of x equals y. So I didn't change anything. I just switched the side of the equal signs they were on. So I'm going to do the swirl. So 3 to y equals x. So I'm going to create my chart. This time, and this is how it's different, I'm going to choose y values. And depending on what my y value is, my x value is going to change. So if I'm finding my x-intercept, which is what they're wanting me to do over here, my y value is always 0 when I'm finding that x-intercept. So I'm going to substitute 0 in for y. So 3 to the 0 power is 1. So my x-intercept is 1, 0. And then I'm going to choose another y value. So let's say I choose 2. So I'm going to substitute 2 for y. So 3 squared gives me 9. So my next ordered pair that I can graph is 9, 2. So I go over 9. And I go up 2. So there's another point. Okay. So let's say I choose y to be -1. 3 to the negative first is going to be 1/3. So 1/3 -1 is another point. So there's 3 points that I can use to help me graph it. And this is going to get really close to 0 on this left side over here. I don't like that much. And there we go. So now I can see my end behavior a little bit different. So as x goes to infinity, my graph is going to go up to infinity. As x approaches, now x is not going to go to negative infinity. It's going to go to 0, or it's going to approach 0. And when my graph, or when my x values are approaching 0, my graph is going to negative infinity. Okay? Now, the next one is a little bit different because it seems like it would go like this. But this changes that. So we'll see what happens here in a second. So my range is going to be negative infinity to infinity because remember these are inverse functions. So exponential functions, my domain was negative infinity to infinity. So for logarithmic, my range is negative infinity to infinity. My asymptote is going to be x equals 0 because my graph is not shifting left or right any. We'll deal with shifts when I get back on Monday. And so now let's start graphing or filling out a table to see how this is going to graph. So I'm going to rewrite it as log base 1/2 of x equals y. And then I'm going to do the swirl. So 1/2 to the y power equals x. So when I create my table, this goes in my x spot, and then y just goes here. So first they want me to find the x-intercept, so I'm going to substitute in 0 for y, and I'm going to get 1 for my x value. So my x-intercept is 1, 0. Then I'm going to substitute 2 in for y. So 1/2 to the second power is going to give me 1/4. So 1/4 and 2 is going to be about right there. So when y is a positive value, it's given me a fraction. So let's make it negative. Y to the negative first, so I'm going to have 1/2 to the negative first power, which is going to give me 2. So my next point is 2, -1. Let's look at -2. 1/2 to the negative second is going to be 4. So 4, -2 is my other point. So my graph is looking something like this. So my domain goes from 0 to infinity again. It's not increasing anywhere. It's decreasing from 0 to infinity. And then I just fill in my behavior. So as x approaches infinity, my graph is going to negative infinity. As x approaches 0, my graph is going up to infinity. So that's my video. There's another video of the ladies whose curriculum we're kind of using. You can watch that as well. If some of this isn't clicking, you'll have to go in between these two because I didn't do all of the notes for each one of these sections. Your homework is homework 4. And you get to choose evens or odds. And then homework 6, you're just going to do number 1. And we will go over all the homework on Monday. So if you have any questions, write them down and we can go over them on Monday. I hope you guys have a good weekend.